Your radar suddenly picks up an enemy early warning aircraft. You immediately activate the 92 N6E engagement fire control radar to lock onto the target. It uses X-band waves to illuminate the target. This extremely high-frequency velocity irradiation provides accurate coordinates and speed data. Then, you immediately launch a 40N6 missile. The missile quickly climbs to an altitude of more than 30 kilometers to gain the best line of sight and minimize air resistance. After that, the ground fire control radar uses a data link to send course corrections straight to the missile, informing it of the AWACS's latest position and guiding it towards the target area. When the missile approaches the target, ground radar waves spread too wide, causing an error of hundreds of meters. At this moment, the 40N6 missile turns on its own active radar to scan the area, autonomously locking on to the early warning aircraft. But the enemy AWACS has been hiding 400 kilometers away, out of range, so the missile misses the target. But this time, the enemy AWACS never dares to get close to your location again. Then, the radar shows another threat. A hypersonic missile is approaching. The shell of this missile is extremely rigid, and relying on proximity-fused fragments won't destroy it at all. So, you use the Patriot Pack 3 MSE interceptor. However, the altitude of this missile is 40 kilometers, and it is traveling at Mach 10. It is impossible to intercept now. Just wait quietly. The missile starts to dive at a distance of 80 kilometers from you. At this moment, as it hits the dense atmosphere, its speed is forced to drop. At this point, you immediately launch the PAC-3 MSE to intercept. Meanwhile, ground radar keeps tracking the position of the dagger and constantly corrects the flight path of the interceptor through the data link. In the final seconds, the interceptor activates its Ka-band millimeter wave active radar. This radar is highly accurate. You can clearly see the exact location of the dagger. Simultaneously, the double pulse engine undergoes secondary ignition. The dagger attempts to maneuver to evade interception, but the interceptor immediately activates the miniature solid rocket thrusters on the front of the fuselage, pushing the missile's warhead sideways in an instant. The two missiles collide at an extremely high speed. The huge kinetic energy instantly smashes the hypersonic missile into pieces. Suddenly, the Sentinel radar picks up 8 Tomahawk cruise missiles. They are flying towards your position at an ultra-low altitude. The system immediately launches multiple AMRAAM AIM-120 missiles at the incoming threats. At this point, the Sentinel radar on the ground continues to track the Tomahawks and constantly corrects their position through the data link. In the final stage, the AIM-120 missile turns on an extremely powerful Doppler active radar with target sharpening capability. The seeker automatically filters out ground clutter and bites down on the fast-moving missile. When flying next to the Tomahawk, it blows up its high-explosive warhead. A circular cloud of fragments created by the explosion instantly cuts off the Tomahawk's control surfaces and destroys the engine, causing it to spin out of control and crash. However, due to the proximity, 2 missiles successfully break through. At this point, the M1's fire control radar catches them. The system sends data to the launcher to guide the radar to fire and lock onto the missiles in real time. Then, the 9M330 air defense missile is launched. The vehicle-mounted radar tracks the Tomahawks and its own anti-aircraft missiles, constantly launching radio correction instructions. When the anti-aircraft missiles fly within a few meters of the Tomahawk, the radar proximity fuse senses the target and detonates the warhead. The explosion sprays a lot of fragments, severing the Tomahawk's wings and engine, causing it to crash. When you are in shock, there are a lot of cheap cruise missiles on the radar interface again. There are more than 100 of them. These cruise missiles come out of the valley. It was only 15 kilometers away when you detected them. You immediately launch multiple anti-aircraft missiles to intercept. You destroy a dozen cruise missiles, but then a fatal problem arises. A single $400,000 anti-aircraft missile to intercept $20,000 cruise missiles. This cost imbalance is enough to make any defense system unsustainable. Only a strong autonomous supply base can support long-term, high-intensity strategic consumption, creating an advantage that really translates into cost-effectiveness on the battlefield. Back to the battlefield, you quickly adjust your strategy. The Skylex air defense system is activated. The tracking radar of this system, through the fusion of multi-mode sensors and the removal of clutter interference, establishes a 4-dimensional motion model of the cruise missiles. As the missiles approach 5 kilometers, the 30mm cannon launches extreme speed, airburst, pre-fragmented ammunition. When the shell passes through the muzzle sensing device, the system measures the actual muzzle velocity of each round in real time and programs the detonation time according to the target distance. The command is written inside the ammunition in an instant. At the predetermined detonation point, the projectile releases a tungsten alloy shot. These high-density projectiles projectiles form a continuously expanding cone-shaped cloud, turning the incoming missile into a sieve. It only takes a short burst to destroy a missile. The cost is approximately $4,000. Multiple Skylex units working simultaneously soon blow all these missiles back. Don't wait for you to breathe. Dozens of rockets suddenly fly in the other direction. Rockets travel too fast for the Skylex system to intercept, but the cost of intercepting with missiles is too high, so you immediately use a high-energy laser system. The targeting radar faces dozens of fast-moving targets, performing threat assessment through AI prioritization algorithms. Then the auxiliary infrared tracker locks onto the rocket's most vulnerable fuel tank wall. The laser outputs at full power. Under continuous irradiation of 100 kilowatts, the rocket skinning reaches thermodynamic failure in 1.3 seconds, causing structural disintegration. The system immediately switches the energy output and jumps to the next target in the series. By continuous irradiation, these incoming rockets are destroyed. When the last wisp of smoke dissipates, the battlefield returns to silence.